everyone. Today I will introduce the Fronthaul interface of Adherence. Okay, so first, why Adherence is happening now? The driving force is the network densification and the scalability limitation of traditional architecture and priority network dependence, and also to virtualization the network requirement. These are the main reason to make us to development the Adherence architecture. And for Adherence, you have some objectives to optimize the network utilization. First is increase network resource utilization, like slicing, pooling, and then send coarse resource as data centers, and the power space saving. Final is to automate automation, or you can call extraction, and then we will expect some gains to optional efficiency. First, to capex reduction, and OpEx reduction, and the final is to revenue the maximization. So these three parts is about why we need Adherence, and the goal of the Adherence, and what's the expected expected outcome we will get. And then we start to introduce the Fronthaul interface of Adherence. The first is about the split architectures. What is a split Fronthaul? With advent of 5G, the industry realized the need for better standardizations of RAN in general, and functional split is very important. So during the 5G study in release 14, the 3GPP have considered the multiple splitted variants, like figure shows, from option 1 to option 8. There are various options about how to split the layer of the genome B, or you can call the base station. So where is the Fronthaul interface? The Fronthaul interface is the option split 7.3 to split 7.1. So according to the requirement or the designing, you can choose one of them to split the ODU and the ORU, and about the trade-offs between ODU and ORU. Why we need the split Fronthaul? Because in general, the required Fronthaul bandwidth becomes small as more function becomes entrusted to the ORU. So how to balance the function splitted to ODU and ORU is important to Fronthaul interface, because more functions related in ORU will affect the efficiency of the GNOB. But if we split it to two less function to ORU, it will also increase the payload of the ODU. So how to balance the functions is important idea to split it. So like placing IFFT or placing the downlink pre-recording in ORU, this will help to efficiently transmit the data. And like the resource element mapping, the mapping on ODU side is better to GNOB to simplify the control signal on the Fronthaul. And the hard if base split option, like previously we said, base split option will affect the efficiency of the GNOB. So for Owen, they decide the split option 7.2x to be their Fronthaul interface, like the figure shows. The option 7.2x actually is split almost equal functions to ODU to ODU and ORU. Yeah, so you can see the number of functions in ODU and the ORU is almost the same. So I think this is why they use the 7.2x to be the Fronthaul interface, because the payload of the ODU and ORU will be balanced. And it also has other sub options, like the category A ORU or category B ORU. The difference between these two is the category A ORU do not have recording functions, but the category B ORU has. So this is the main difference between them. So then I will talk about the block diagram, the plans, and the protocol mapping. In option 7.2x, it decides the control plane, user plane, and the synchronization plane, and the management plans. These four plane is the main places to classify the data. And the figure shows the block of land in the architectures. So final, in the 7.2 simulated option, the communication between ODU to ORU will like the figure shows. ODU schedule the resource and the 7.2x interface, like the the Fronthaul interface will utilize the PRBs are sent and synchronized over the ORU interface. Then ORU will resemble the PRB per OFDN and the symbol, including the empty PRBs. So then final, the ORU will send the data like the allocations. So this is all about the Fronthaul interface, the simulated 7.2x, what the orange choose to be the Fronthaul interface. Thank you.